Hey guys, so back again. So we are going to be looking at some examples of infinite limits. So we're going to look at again, so let's just review. So we're going to be looking at infinite limits. So these are limits that approach where x value approaches some number, and the result is something very, very large. So we're going to be looking at infinite limits, limits that equal infinity, positive or negative. So let's just recall before we get there, we're going to be dealing with a lot of rational functions. So let's recall some properties of rational functions. So recall when a common denominator is divided out, a whole occurs. So again, this is when you get 0 over 0, a whole occurs when you can divide out that 0 over 0. When a factor cannot be divided out, a vertical asymptote occurs. And that we, again, so that was a non-zero number over 0. All right, so let's look at this first example. So the first example, f of x equals negative 2x squared minus 2x plus 12 over x squared minus 6x plus 8. So we're going to be looking at two limits. We're going to be looking at the limit as x approaches 4 from the left and as x approaches 4 from the right. So again, a little bit smaller than 4, a little bit bigger than 4. So let's look at this. We're going to look at it analytically, and we're also going to be looking at it graphically in just a second. But let's look at this analytically first. So analytically, we're going to take our original equation, and the first thing that we're going to do is factor out a 2. So all of these are multiples of 2, so we're going to factor out a 2. And after we do that, then we can, I also factored out the denominator, so we can factor out the denominator, x minus 4, x minus 2. We can also factor out the numerator, so let's do that. So we can factor out the numerator as well. So we can factor out the numerator. So at the numerator, we have this numerator cancels out. This is where there's a whole, so there's a whole here at x equals 2, and there's going to be an asymptote right here. This one was not divided out, so there's going to be an asymptote right here. So let's look at it though. So we know graphically that there's going to be a vertical asymptote right here at negative 4, and there's going to be a hole at positive 4. X is positive 4, and there's also going to be a hole at x is positive 2. But let's look at this. So if we get, so this right here tells us that we're looking at at numbers that are slightly smaller than 4. So slightly smaller than 4. So we could say probably about, we could say 3.9. 3.9 is smaller than 4, about. Well, this, if we were to plug in 3.9 into our equation right here, we would get about, if we rounded, we would get about negative 14. So if we have 4 plus 3, 7, 7 times negative 2 is negative 14, over, this is going to be a negative small number. 3.9 minus 0.4 is negative 0.1. If you make it, if we bring in this, if we get this number closer and closer to 4, it's going to be a very, very small number, but it's going to be negative. So it's a negative small number. So we're going to have some negative value. So a negative over a negative is going to give us a positive value. And like we said before, 14 over a really small number is going to get us a really large number. So I will show you guys on my calculator phone. So if we have here, so negative 14 over a very small number. So if we have 14 and if we made this negative over a very small number, so 0.0001 maybe, we get a very large negative number. So this number, oh, sorry, I didn't do that right. 14 negative divided by a very small number, and this one's also negative, gives us a very large number. 1 million. If we make this number even smaller, it'll be even larger. So this number tends towards positive infinity. whenever we have a fraction and the denominator is really small, the result is an infinite value. Let's look at this next one. It's either going to be positive infinity or negative infinity, depending on what these signs are. The sign was positive, negative, and negative. Let's look at this one. So if we have the same one, but as we look to the right, so these ones are numbers that are a little bit bigger than 4. So again, our numerator is going to be about negative 14. Our denominator, however, is going to be a positive number. 4.1 minus 4 is a positive value, and it's going to be very, very, very small. So as we get really, really, really close to 4, it's going to get smaller and smaller and smaller and smaller and smaller and smaller. It's going to be almost to 0. So negative 14 over a very small number is a very large number. Negative though, positive over negative, so this is going to be a negative large number. So if we graph this, let's graph this. So we're going to graph this. So we know that there's going to be a vertical asymptote right here at positive 4. There's also going to be a hole at positive 2. Okay, so we said here as we get closer and closer to 4 on the left side, so on this side, so as we get closer and closer to 4, our number gets very, very, very large. So as we get closer and closer to 4, so I'm going to start off a little bit far away from 4, so maybe at 3 or so, but as we get closer and closer to 4, this way, so as we move in closer to this line, the number gets larger and larger and larger. The y values get very large. The y values are going to get very large right here. This one tells us that as our numbers get very close to 4 on the right side, so going from this side, our numbers get very, very, very negative. So very, very, very negative. It doesn't tell us about this behavior, but I am going to tell you that there is a horizontal asymptote right here at 2, so at y equals negative 2. But we don't really have to do that, but it's going to look something like this. We said there's also a hole here at 2. So right here, there's going to be a hole right there instead of sorry, that looks like a filled in circle. It should be an open circle. That's open. All right, and then this one's also going to swing back around over there. So this is what this graph is going to look like. And what we can say is that if x tends towards a from the left, as x goes towards a from the left, of f of x is equal to infinity or negative infinity, or if we look at the limit from the right of f of x and the result is positive or negative infinity, then a is a vertical asymptote. So we said as we get closer and closer to 4, it goes towards infinity, closer and closer to 4 from the left, I should say. Closer and closer to 4 from the right, it goes towards negative infinity. So there are those asymptotes. So we're going to look at one more problem. And this one says, I gave you guys the answer. So we're going to be finding the vertical asymptotes, and we're going to use this by finding or doing some factoring out. So we're going to factor. So here's our problem. We're going to factor out. We're going to cross out our common factors. So these factors right here, there's going to be a hole right here, and there's going to be a vertical asymptote right here. So the leftover ones, the ones that remain, are going to be our vertical asymptote. So we have a vertical asymptote at x equals 2 when this is equal to 0. So we're going to justify using limits. So this is using algebra, so using your knowledge of algebra. We're going to justify using calculus, so using limits. So as x gets closer and closer to 2, so as we get closer and closer to 2 from the left, so these numbers, so say a little bit smaller than 2, you can say about 1.9. So our numerator is going to be about 3. Our denominator is going to be very, very, very small, and it's going to be negative 1.9. So I'll prove it to you guys. 1.9 minus 2 is some negative small number. If we make it even closer, 1.99 minus 2, it's an even smaller negative number. It's the numbers are going to be negative, and they're going to be very small. So remember, we said some number over a very small number is going to be infinity. This is positive over negative, so it's going to be negative infinity. And again, if you want to convince yourself, you can plug in 3 over some very, very tiny number. It gives you a very large number. Same idea with this one. So we have here, as we approach from the right, we have, as we approach from the right, so this is still going to be about 3. This one's going to be a positive small number. 2.1 minus 2 gives us a positive number that's small, and as we get closer and closer to 2, the number gets smaller and smaller, the difference gets smaller and smaller, so we're going to also have that going on. So I said that we already have a horizontal asymptote at 1, or at 2, at y equals positive 2. We'll go over that on Monday, but we also have a vertical asymptote at positive 2. And we said as x approaches 2 from the left, so from the left. As we get closer and closer to 2, we get closer and closer to negative infinity. So down here, so as we get closer and closer to 2, we get closer and closer to negative infinity. And as we get closer and closer from the right, it goes towards positive infinity. And I already told you that there's a horizontal asymptote. This one's going to kind of look like this. And again, we have a hole at -5, so there'll be a hole around here somewhere at -5. All right, that's all I have for today. All right, view the next one for the secret questions.